So let us discuss a binomial theorem question. So we are given an expansion 1 plus x raised to power n, and we are given the consecutive terms are 165, 330 and 462. So we basically have to determine the value of n. So the problem is that we don't know to what power 1 plus x is raised to. Similarly, we don't know that, let's say, 165 or 330 it's the fifth term or the 10th term. So we make an assumption that rth term is 165. So r plus 1th and r plus 2th term would be 330 and 462. For any binomial expression, we know that general term can be obtained using this expression. In our case, this formula would simplify to this, which further simplifies to r plus 1th term is NCR x raised to power r. So we can say that rth term is NCR minus 1 x raised to power r minus 1. Similarly, r plus 2th term is NCR plus 1 x raised to power r plus 1. Now we know that rth term is 165. So this means that NCR minus 1 will be 165. Similarly, NCR would be 330 and NCR plus 1 would be 462. So now, in order to solve this question, we'll be using an important result. I'll be proving this result to you after we solve this question. The result is NCR upon NCR minus 1 is n minus r plus 1 upon r. So, from this expression, we can say that NCR plus 1 upon NCR would be n minus r plus 1 divided by r plus 1, which simplifies to n minus r upon r plus 1. So now we are given that NCR, so in our case NCR upon NCR minus 1 would be 330 upon 165, which is equal to n minus r plus 1 upon r. So this happens to be our first equation. Similarly, we are given that so NCR plus 1 upon NCR would be 462 upon 330, which is n minus r upon r plus 1, which happens to be the second equation. So we basically have to solve these equations. We have to basically solve these simultaneous linear equations. So I can solve this. This will become so then we'll be adding these equations. This means that So we have found the value of r as 792 upon 198. So this is equal to this is equal to 4. So we found that r is 4, and similarly then we can substitute the value to find n. We can use the equation 330 upon 165 is n minus 4 plus 1 upon 4. Similarly, 330 upon 165 can be simplified to 2. So n minus 4 plus 1 upon 4. So 8. So basically n comes out to be 11. So basically the answer in our case is 11, and we have found the value of n.